we did the exponent laws, and then we figured out yesterday after doing different tables, filling out different tables, and then investigating the exponents, we figured that anything that's to the power of 1 over a value, that's the same thing as writing the nth root of that value, right? So if I have a to the power of 1 over n, that's the same thing as doing the nth root of a, right? You remember that from yesterday? All right. So today we're gonna look at what happens if I have a to the power of a number divided by another number. Okay? So it's not 1 anymore. It's 2 over 3, or it's 3 over 7, or whatever it is, right? So it's a number over another number. What's gonna happen to them? So we're going to use the calculator to complete the following tables. So what I want you to do is on the calculator, you're going to put, instead of a, you're going to replace a with the value 1, 4, 9, and 16. And then we're going to try to find the answer for that. To do this on the calculator, you have to do 1, for example. And then you're going to press the power button. It's either, the power button are either x to the power of y, y to the power of x, or the hat button. And then you're going to put the exponent in brackets. So you're going to do 1 power bracket 1 divided by 2. Make sure that you put your exponent in bracket, otherwise it's not going to give you the right answer. Unless your calculator is fancier, and then you can do it. At once. So you guys are going to have to give me the answers as you go. So the first one is 1 to the power of 1/2. So that's going to give me 1, right? It's the same thing as saying, so can you tell me what would this be as? Like what would this be the same as doing on the calculator? Rooting the value, right? So if I do the root of a, that's the same thing. Yeah? Okay. So square root of 1 is 1. So if I'm going to do 4 to the power of 1/2, what am I going to get? 2. 9 to the power of 1/2. 3. 16 to the power of 1/2 should be 4. Should be 4. 16 to the power of 1. Okay. Now what we're going to do, we're going to do the same thing, but instead of a power of 1/2, we're going to do power of 3 over 2. So what's 1 to the power of 3 over 2? 1. What's 4 to the power of 3 over 2? 8. What's 3 to the power, 9 to the power of 3 over 2?
27.
And 16 to the power of 3 over 2?
64.
Okay, can I have your attention here for a second? We'll get back to this. So I want you to compare what you have seen in this column right here, and with this column. Do you see anything special?
Yep.
What do you see?
It's going to be the lowest multiple that can be divided.
So can you compare, let's say, the 2 and the 8? So when I did the square root of 4, I got a 2, right? But when I did 4 to the power of 3 over 2, I got 8. Why is that? What is 8 compared to 2? What do I raise 2 to the power of what to give me?
4.
2 to the power of what gives me?
Oh.
2 to the power of 3 gives me. Okay? Try it on the calculator.
Which term is to the power of 3?
How about 3 to the power of what gives me 27? the power of 3 gives me 27. How about 4? 4 to the power of what gives me 64? 3. Okay, keep that in mind. Okay? Now let's do a to the power of 5 over 2. So 1 to the power of 5 over 2 is 1. 4 to the power of 5 over 2? 32. 9 to the power of 5 over 2? What is it? 123?
243.
Oh, 243. And 16 to the power of 5 over 2?
1024.
1024? Okay. Now let's do this. Let's compare, again, eyes on me. Let's compare this, the square root of a, to what we just got. If I want to do 2 to the power of what gives me 32?
5.
2 to the power of 5. How about 3? 3 to the power of what gives me 243? 3 to the power of what gives me 243?
5.
5.
5.
4 to the power of what gives me 1024? 4 to the power of, try it, gives me 1024. So what I'm doing here is I'm taking this, right, which is the square root of a, and I'm raising it to the power of 3, right? If I take this and I raise it to the power of 3, that gives me a. If I take 3 and raise it to the power of 3, that gives me 27. Yeah? For this one, if I take the square root of a, which is this, and I raise it to the power of 5, it gives me this. Now, between this that I just wrote and then the one that we did on the calculator, do you see any common? Anything common? So, do you see anything common between this that I just wrote here and this? Where does the square root come from? The denominator, right? Because I have a 2 in the denominator, I'm square rooting, right? And where does that power of 3 coming from? From the numerator, right? You see that my denominator became the root and my numerator became the power. That's not a coincidence, right? It is not. This is something that, you know, it's gonna happen every single time. Now, why is that? Let's look at why is that. If I think about this, how can I write the square root of a as a fraction power? A to the power of,
3 over 2.
now let's look at it as 1/2, right? To the power of 3, yeah? That's the same thing? That's the same thing, right? If I change the square root into a power of half, that's the same thing. Yes. Okay? And then to the power of 3. Now, what did we learn yesterday about the power to the power? What do I do with that? I multiply. What's 3 times a half? 3 over 2. So you see how this and this are the same, right? Because this is to the power of a half, and then to the power of 3. The law says if I have power to the power, I have to multiply the powers. When I multiply a half by 3, it gives me 3 over 2. So anytime you have a power that's a fraction, the bottom goes into the root. So if I have a bottom is 2, I don't write the square root. This is kind of given to me, right? And then I raise 8 to the power of the numerator. There's different ways that you can write this. You can write it like this, or you can write it like this. It gives you exactly the same answer. Do you guys understand what's happening? Okay. So, let's look at this. So this is the same thing as doing 8 to the power of 1/3 is the same thing as doing what? Square root?
Cube root?
Cube root. Cube root, right? Cube root because my denominator is 3. So cube root of 8. So I want you to do cube root of 1. Cube root of 8. It's going to be 2. Cube root of 27. 3. Cube root of 64. Good. Now, without doing anything, eyes on me for a second, what do you think the answer is going to be for a to the power of 2 over 3?
And then it's going to be the power.
So it's the cube root of a to the power of 2, right? So I can take this, because that's a cube root of a, and I can raise it to the power of 2. Yes? Let's try it. So without using the calculator. So cube root of 1 is 1, to the power of 2, that's going to be 1. Right? Cube root of 8 was 2. Yeah? If I raise 2 to the power of 2, what do I get? 4. What would this be? 9. Right? Because cube root of 27 is 3. 3 to the power of 2 is 9. Cube root of 64 is 4 to the power of 2. Now, I want to use your calculator and do a, which is 1, 8, 27, 64, to the power of 2 over 3. See if the answer for that matches the answer that we just got without using the calculator. They match, right? Good. Now find me the answer for the other thing. What's 3 to the power of 5? 243. Are you guys okay with this? So this is the same thing as doing, on the calculator, you can do the cube root of a to the power of 5. All right. So let's write the answers here. So compare the entries in the second, third, and fourth column of each table. How do the values 8 to the power of 3 over 2 and 8 to the power of 5 over 2 relate to the values of 8 to the power of half? We said that 8 to the power of 3 over 2 is the same thing as 8 to the power of half and then to the power of 3, right? We said that they're the third power, so it's like raising them to the power of 3 for the square root of a. And then the value for a 5 over 2 is the same thing as raising a half to the power of 5. and then for the second one, it was the same thing as rising a 1/3. To the power of 2. And then so if I have the formula a to the power of m over n, how can I write this as a radical term? So there's two things. This is called rational. Rational means fraction. Okay? Rational means fraction. And then we can change it to radical means root. Okay? So the radical means the root. I'll write that in a bit. So if I want to write this as a radical, what do I do? What do I write here? The nth root of a to the power of m, so you can put it here, or you can put it here. It's the same thing. Okay? Are we good with that? So, this is called the radical, or okay? Can I move on? All right. So we're going to do a few examples where we're going to go from a radical to a rational, and then from a rational to a radical, and then we're going to find the answers. So let's recall the formula. So the formula was what? If I have a to the power of m over n, how can I write that? Root n of a to the power of n. So there's conditions for this. So the values of m and n, they have to be specific values. So this is the radical, or the nth root of a to the power of m, or it's the same thing as writing this. So the conditions are the following. M has to be an integer. So m can be positive or negative, but it has to be a whole number. Okay? So an integer is a whole number, positive or negative. Okay? N is a positive integer. So n, you can't take the negative root. So you can't have, like, you can't have the root of -3. That -3 root, it doesn't happen. Okay? So if you had, let's say, if you had 3 to the power of -2 over 3, the -2, the negative is going to be with a 2, not with a 3. It's never going to be with a 3. It's never going to be with a denominator. Okay? So that negative is never going to be with the denominator, because you can't put the negative in the root. Do you guys understand that?
Can we put it as a power?
What is it? So yes, so if you have, let's say, a to the power of negative 2 over 3, let's take that example, right? So it's going to be the third, the cube root of a to the power of negative 2. That's fine, right? But I can't write as negative 3. So if I have this, that negative, I have to bring it up to the numerator. I have to write it like this. It's the same thing as writing this. That's it, right? Doesn't matter where the negative is, top or bottom, doesn't matter. Okay? But in our case, it has to be with the top, with the numerator, because otherwise I can't take the negative root. Okay? If I write this or this, these are equal to each other, right? They're the same. But because of my rules, it can't be with a denominator because I can take the nth root, or the negative nth root. Are we okay with that? Now, can I do this?
Yes.
Can I do square root of negative 50?
Oh, yeah, that's
Try it.
right. No, it's a math error.
It's a math error.
You do cube root.
How about if you do this?
How do you get the 4 there?
There's the
Oh,
n. Can you do that?
no, you can't.
You can't do 4?
You did it.
You just did it?
You just did the 4.
Just do 4, and you press shift this. Yep, and then negative. Hmm? Still an error, right? So do 4. Shift. Because you did cube root, you didn't do
I know,
4.
I did 4.
Now, okay. Can you do cube root of negative 50?
Yes. For some reason.
This one I can't do, right? Can you do cube root of negative 50? Try it. Yes. Can you do sixth root of negative 50?
No.
No. Can you do fifth root of negative 50?
Yep. Yep.
Okay, now look here. Why are these a yes while these are no's?
Even numbers.
You see the even roots here? This is a 2, right? That you don't see. You see the even roots here? You can't take an even root of a negative number. Why is that? What's the opposite of root? Square. What's the opposite of fourth root? Power of 4, right? Okay. So if I erase something, if I erase a negative 20, or a negative 2, let's put it that way, to the power of 2, what does that give? Positive 4. If I raise a negative 10 to the power of 2, what does that give? Positive 100. So anytime I raise it to an even exponent, what is my answer going to be? Positive. It's never going to be negative, right? So because the root is the opposite operation of the square, right? If I want to find this answer, I'm going to have to do root, right? Yeah? So because of this, I can never do an even root of a negative number. Okay? So it will never work. If you have a negative number and an even root, it is not going to work. It's an imaginary number that we don't talk about in this class. Okay? So, when you have, if n is even, then A has to be positive. It doesn't matter. It could be positive or negative. If n is odd.
If n is an odd number.
Then it can be either positive or negative. It doesn't matter. Okay? Now, remember I told you when I say radical, I mean root, so I want the answer in the root format. If I say rational, I want it in the fraction format. Okay? So let's look at this question. So rewrite each expression using rational exponent. So in this case, I want to put it in rational. So I want to put it in fraction. Now, how will I write root of 25 in rational?
25 to the power of 1/2.
Perfect. Okay? That's all what the question is asking me. It's not asking me to evaluate, right? If it's asking me to evaluate, what would be my answer?
5.
Now, how about cube root of negative 125? To the power of 1/3, right? Make sure that your negative 125 is in bracket because that one negative 125 is all under the root. So I have to put it in bracket and make it to the power of 1/3. Yeah? Now, what would be the answer for this? I want to do negative 5. That's doable because my root is an odd number. Yeah? So it's okay. How about this one?
1.05 to the power of 3/4.
That's right. So it's 1.05 to the power of 3/4. This goes in your denominator. This goes in your numerator. You guys good with that? Okay. How about the next question? So the next question is asking you to rewrite each expression in radical form. And then evaluate. So it's asking you to do two things. Writing it in radical form and then evaluate. So how would I write 81 to the power of half in radical?
Square root of 81.
Square root of 81. And what would the answer be?
9.
Perfect. How about negative 64 in brackets to the power of 1/3?
Cube root negative 64.
Mm-hmm. So what's the cube root of negative 64?
Negative 4.
Negative 4. And then for this one, how would I write in radical format?
Maybe 32.
So what would I put in the radical?
5
Fifth root of 32
to the power of 4.
to the power of what?
I never know what to say that.
Now you know. Fifth root. And that's going to be 16. And make sure that you do that on the calculator, right? And you get the answer.
Oh, so you do the, okay. So it's going to be, do the bracket first.
You can write it like this or you can write it like this. It doesn't matter as long as you can, whatever you can do, right? Should give you the